Hello, thank you for checking out Mr. Ware's videos, and today we're looking at a review for a data test. So let's begin. Okay, in question one it says use the data table below to create a given scatter plot, then complete the sentence below. Alright, so here first we're going to complete the table. So for every x, you got a y here. So you go over 7 and you go up to 6 for this one, 7. Go over 7 and then go up to 6 and make a dot, then go over 8 and up to 6 to make a dot, then go over 3 and up to 4 to make a dot, and so on. So once you do that, you should have this. Alright, so 0 0 1 1 3 4 4 4 and so on. Alright, the next part is you're supposed to complete the table or complete the sentence here. So the scatter plot shows negative or positive correlation because as the plot of values of x increase, the values of y generally decrease or increase. Okay, so as you can see, this is going up, so it's going to be positive. And the reason being is because as the x values go up, the y values go up. So it increases. So as the x increases, the y increases. All right, let's look at question 2. All right, so here it says describe the correlation in the scatter plot below. So this one, the scatter plot's already done, and we're just trying to describe it. Okay, so the scatter plot shows blank, and it gives you a word bank, and it's kind of hard to see, but positive linear with an outlier, negative linear with an outlier, or non-linear. So if it forms a line, then it's linear. So let's first figure that out. Do you believe it forms a line? The answer to that is yes. It starts to have a line here. It's not perfect, but there's a line. Now the next question is it positive or negative? Is it going up or is it going down? Well, it's going down, so it's negative. Okay. Now the last question is there any outliers? Is there anything different from the group or the majority there? And the question is yes, or the answer is yes. This one right here is an outlier. So it's going to be negative linear with one outlier. All right. Now, after you say that, you're going to say correlation because as the plotted values of x increase, the values of y generally go in which direction? Down. So it's going to be negative because it's decreasing. As the x goes up, the y goes down, except for the outlier. All right, next question. All right, now a researcher studied the relationship between the number of times a certain species of cricket will chirp in 1 minute and the temperature outside. Her data is expressed in the scatter plot and the line of best fit below. What does the slope of the line represent? So they made a scatter plot. They drew a line of best fit. Okay. Understand there's no dots on that line. The line is just not exact. It's just drawing a line of best fit here. Okay. They want to know what this line means. Okay. All right. Now, these are the type of questions you really want to practice on because they can ask any different kind of question. They can ask you about the x, they can ask you about the y, they can ask you about the slope, they can ask you about one of the dots. These are the questions you really definitely want to make sure you know out of Delta Math, okay, because it could be any kind of question. Now on this one, we're talking about the slope. what does the slope of the line represent? And then anytime you talk about slope, you're talking about the rate of change and how something changes. Okay, so here we've got the expected change in temperature in degrees Fahrenheit for each additional cricket chirp in 1 minute, the expected change in the number of crickets chirp in 1 minute for each additional degree Fahrenheit, or the expected temperature when the cricket chirps 1 time. Notice how there's no change in that one. And how long the cricket continues to chirp. That there's no change there. So the two that it has to be, because we're talking about slope, is either A or B, representing a change. Well, here they're saying the expected change in temperature in degrees Fahrenheit for each additional cricket chirp, right? So in the previous questions we talked about, as X increases, what does Y do? So X is the input, Y is the output. Keep that in mind, okay? So here in B says the expected change in the number of crickets in 1 minute for each additional degree Fahrenheit. So one is saying when the temperature changes, how does the cricket chirps change? And the other one's saying as the cricket chirps change, how is the temperature changing, right? Okay, so we want to go with the latter, A. It's the only one that has the crickets as the input and the temperature as the output. All right, let's take a look at another question. Okay, here it says determine the type of correlation represented in the scatter plot below. Okay, this is pretty simple, straightforward. We're looking at the correlation and how strong it is. So you can have a lot of different types of dots. You can have one where it's scattered all over the place and you can't see a line. You can have one where you see a perfect line. You can see one where it's kind of strong. You can have one where it can have a line but it's weak. It's not really that close together. Okay, so the more spread apart it is, the weaker it is. But if it's so spread apart you can't tell where the line is going up and down, then it doesn't have a correlation. Okay, so first let's determine, is it positive or negative? Okay, it's negative, it's going down. Okay, next, how strong is it? Okay, you could pretty much see a line here. It's not a perfect line, but it's pretty strong. It's not weak. You don't have dots here, 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 and here. They're pretty close together there, just not perfect. Okay, so this is going to be strong negative correlation. Strong negative correlation. It's going down. It's not perfect, but it is strong. So this is another one you want to practice and make sure you get right. Okay, let's take a look at this last question. All right, it says the annual profits for a company are given in the following table, where X represents the number of years since 2004 and Y represents the profit in thousands of dollars. Write the linear regression equation that represents the set of data rounding all coefficients to the nearest 100. Using this equation, estimate the calendar year in which the profits would reach $304,000. All right, so here we go. We've got 2004, and 2004 is 0. 2005 is 1. 2006 is 2, and so on. And here's the profits in thousands of dollars. Okay. What we want to do is write an equation, linear regression equation, and we need to have the final answer to the question, like what year would it be where they reached, close to $304,000. So you can see it's going up, right? So this is what you're gonna do. You use technology. You're gonna click on this copy value for calculator. You click on this button, and then you click on Open Statistics Calculator. You're gonna paste it. You're gonna click the right tab, and I got a separate video that goes verbatim through that and shows you how to do every single step there. But here I went ahead and got the end results, which is this right here. We've got y is equal to ax plus b. You got A, which is 26.9. You got B, which is 139.9. And you're going to write out the equation. And this is what the equation looks like. Okay, this right here will go in this box right here, this equation. Now, there's two types of questions. Either they give you the X and they want to know the Y, or they give you the Y and want to know the X. Okay? They're both pretty easy, but the one that is a little more difficult is when they give you the Y and you want to know the X. Okay? If they want to know the actual Y, all you gotta do is put in whatever number they want you to put in here. And a lot of times you have to subtract the year from the year they want to get that number. And then you plug that number in here and just solve it, and you'll find Y. You just type that answer over here. And you want to make sure you round everything to everything you're supposed to round it to. Sometimes they want you to round the coefficient to the nearest decimal. Alright, so in this one, we're looking for the X. So they give us the Y, and we're going to plug that in right here. $304,000, and we plug this in. And it's a simple two-step equation. You're just going to solve it. So you're going to subtract negative 139.9 on both sides. That's going to bring down to 26.9x, and here you get 164.1 is equal to 26.9x, and just going to divide the coefficient here. Okay, that cancels out, and that leaves you with x is equal to 6.1. All right, so now we just got to figure out what year is it. So it's going to be 6 years from the first year, which is 2004, and we got to find the calendar year. So that's going to be 2004 plus 6, which is 2010. So our answer is going to be 2010 here. And again, like I said before, this is the equation. This is the equation that we came up with right here that goes in this box. And that's it. That is the review for the data test. I want to thank you for checking out Mr. Ware's videos. Have a nice day.